This is our Milky Way, reconstructed from data collected by the Gaia Space Telescope. But we have never seen it from the outside. We are only trying to sketch the shape of a monster we are living deep inside. Gaia has tracked about 2 billion stars, recording their positions and motions through trillions of cold, precise observations. From that vast ocean of data, we finally determined where the center of the galaxy lies. Not by traveling straight to it, but by following the orbits of millions of stars circling something invisible. You cannot step outside to see the full picture. No one is allowed to do that. You can only begin here, from your small, fragile position, and slowly feel your way deeper into this system. The journey to the center of the Milky Way is not an adventure. It is a descent into the body of a colossal, ancient creature whose face you have never truly seen. Your solar system lies about 26,000 light-years from the center of the Milky Way. You are not at the center. You are trapped in a small branch called Orion, near the outer edge of the galaxy. Right now, the entire solar system is racing around the center at about 230 kilometers per second, nearly 20 million kilometers each day. You feel nothing, but every second, your body is being carried hundreds of kilometers through a deep, cold void. One full rotation around the galaxy takes about 230 million years. That means from the time the first dinosaurs appeared to their extinction, the solar system has not even completed a single orbit. If you shrank the entire Milky Way down to the size of a large city, your position would be nothing more than an anonymous house in the farthest suburbs. No signs, no coordinates, no one cares where you are, only endless distance and constant motion in the dark. The farther you move away from what feels familiar, the more the Milky Way reveals its true nature. This is not a simple flat plane or a neat, beautiful disk as we once imagined. It is a complex, dynamic, three-dimensional structure with layers of darkness operating at once. At the center lies the bulge, a massive region where stellar density is extreme, light compressed into a suffocatingly tight space. Billions of stars crowd together, spiraling in chaotic motion. Surrounding it is the galactic disk, containing most of the stars, gas, and dust. This disk spans over 100,000 light-years in diameter, yet is only about 1,000 light-years thick, astonishingly thin, like a vast sheet of paper in space. Your solar system is drifting on that fragile layer. The spiral arms are not fixed, elegant structures. They are simply regions of higher density where gas and dust are compressed so intensely that new stars are constantly born under immense pressure. Beyond the disk lies the vast halo, stretching over 200,000 light-years. Here, only ancient, exhausted stars and sparse globular clusters remain, slowly fading into silence. There is no clear boundary, no edge marking where the galaxy ends. Matter simply thins out and dissolves into the deep darkness. Most of the Milky Way's mass does not lie in the stars or gas we can see. It is hidden in dark matter, an invisible substance making up about 85% of the galaxy's total mass. This forms an unseen framework holding the entire galaxy together. Without it, stars at the edges would slow down and the galaxy would tear itself apart. You cannot see it, you cannot touch it, but it is tightening its grip on everything, quietly, coldly, in the dark. Our journey continues deeper into the heart of the Milky Way. At the center is not a bright star or a glowing region. It is a supermassive black hole known as Sagittarius A star. It has a mass about 4.3 million times that of the Sun. It does not shine and cannot be directly observed in visible light. The only thing we can measure is the violent motion of the stars around it. One of the clearest is the star S2. It orbits the center in an elliptical path, completing one cycle in just 16 years. At its closest approach, it reaches speeds of nearly 8,000 kilometers per second, close to 1/6 the speed of light. Fast enough to escape most gravitational forces, yet still tightly bound by this black hole. There is no solid surface, no bottom, only an invisible boundary called the event horizon. Once anything crosses that line, not even light can escape. Everything is consumed forever, completely cut off from the rest of the universe. From that center, if we step back and observe, we begin to see how this colossal machine operates. Stars do not simply exist, they are born from vast clouds of gas and dust within nebulae. When a region becomes dense enough, gravity tightens its grip, pulling everything inward. Temperature and pressure rise violently until nuclear fusion ignites and a new star is born. The remaining material forms a rotating disk where dust particles collide and gradually stick together, eventually forming planets. Our solar system was born this way about 4.6 billion years ago. Inside every star's core, temperatures reach millions of degrees, enough to fuse hydrogen into helium and release enormous energy. When the fuel runs out, a star's fate depends on its mass. Smaller stars collapse into white dwarfs that slowly cool over time. Stars more than 8 times the mass of the Sun collapse and explode as supernovae. In just a few brief seconds, the energy released exceeds the total energy the Sun will emit over its entire lifetime. Temperatures during the explosion rise to billions of degrees, enough to forge heavy elements like gold, uranium, and many others. The remaining core becomes either a neutron star or a black hole. The material ejected from the explosion spreads into space, mixing with older gas and dust, becoming the raw material for the next generation of stars. A single nebula can give birth to thousands of stars this way. This process repeats endlessly over billions of years. And the most unsettling truth is this: the atoms in your body were once deep inside the cores of stars that died long before Earth even formed. The Milky Way does not preserve matter. It continuously destroys and rebuilds everything through long, relentless cycles. Not every region in the galaxy is the same. Closer to the center, stellar density is higher, radiation is extreme, and the likelihood of supernovae is far greater. Neutron stars and magnetars can emit radiation powerful enough to affect their surroundings across vast distances. Events like these could easily strip away a planet's atmosphere if they occur close enough. Farther out, matter becomes more sparse, and high-energy events occur less frequently. Between these extremes lies a relatively stable zone, about 20,000 to 30,000 light-years from the center. Here, orbits are comparatively calm, star density is not too crowded, and the risk from catastrophic events is much lower. Earth lies precisely within this region. Nothing guarantees absolute safety, but this is one of the least hostile locations in the entire galaxy. You exist because of this fragile distance, within a system where most other regions are far too dangerous for complex life. The journey continues. The Milky Way does not stand still. The entire galaxy is moving as a single system at about 600 kilometers per second relative to the cosmic microwave background. That means hundreds of billions of stars and everything within them are drifting through space at a speed we cannot perceive. The Milky Way is not moving alone. It is approaching the Andromeda galaxy at about 110 kilometers per second. The current distance between them is 2.5 million light-years. In about 4 to 5 billion years, the two galaxies will begin to interact violently. Gravity will stretch the spiral arms, tearing streams of stars into long structures known as tidal tails, while compressing gas clouds and triggering waves of new star formation. The night sky will be completely transformed as Andromeda fills nearly half of it. The two galaxies will pass through each other multiple times over hundreds of millions of years. Eventually, they will merge into a massive elliptical galaxy called Milky Way, containing more than 1 trillion stars. Their central black holes will also merge into a larger one. After the merger, free gas will gradually be depleted. The rate of new star formation will decline and eventually stop. The remaining stars will fade, becoming white dwarfs and eventually black dwarfs. Over trillions of years, the galaxy will turn into a vast graveyard of neutron stars, black holes, and dark remnants. Even black holes are not eternal. They slowly lose energy through Hawking radiation and will eventually evaporate over unimaginably long timescales. There is no dramatic explosion, no final climax, only a slow, silent fading until everything sinks into complete darkness. Our journey to the Milky Way ends here, but in truth, it never really ends. You are not observing the Milky Way from the outside. You are inside it, moving with it. This entire process began billions of years before you existed and will continue long after you are gone. Humanity is only an infinitesimal moment in the galaxy's endless history. The Milky Way is not just where we live, it is a colossal machine that forged us from stardust, carries us through vast motions, and will ultimately redistribute everything into a dark future. The Milky Way, the great engine that devours time, continues to turn, and we, in our brief moment, can only look up at it.